Thank you so much for being here today. I hope you're having a fantastic Reinvent. Welcome to scaling up to your first 10 million users. Now, as your web application becomes more and more popular and you're attracting more and more users, how do you ensure that those users continue to have a great experience? So that's what this talk is all about. My name is Ben Thurgood. I'm a Principal Solutions Architect from Sydney, Australia. It's a 200-level presentation. Does anybody recognize this game? Any Australians in the audience? It's Australian rules football, and those goalposts in the middle, if you get it through the middle, it's 6 points, and if you miss, you still get a point. That's pretty good. So let's talk about your goals. How many people in the audience today are building or operating a web application? Almost everyone. And out of you, can we do a little bit of a survey? Who's got thousands of users currently? Quite a number. And what about tens of thousands? Okay, quite a lot. What about hundreds of thousands? It's getting big. Yep. What about millions? Okay, cool. Tens of millions? Okay, I can't bring anyone up on stage with me. But if you saw hands go up in a segment a little bit above where you're at the moment, potentially that's someone you might want to have a chat to. So, congratulations, you've done a great job up to now. Your web application's popular and it's growing in popularity. Unfortunately, I guess that means you also need to know how to scale and keep ahead of that request volume increasing. Now, you might find you have to deal with sudden increases in scale, like one of my customers whose request volumes doubles every year, around September timeframe, and has done for 5 years in a row. That's a fantastic high-value problem to have, but it makes them very nervous around the September timeframe. Or you might be dealing with constant, steady-state growth. Either way, you want to know what to do to stay ahead of that. So the concepts and ideas I'm going to go through today will help you no matter where you are in that journey. All right, so we're going to talk about scaling on AWS. And as technologists, what do we do when we want to find out about something? We look it up. So if we look up scaling on AWS, we're going to get a lot of hits and lots of references to auto-scaling. That sounds fantastic, right? Just turn that on, pretty much done. Unfortunately, it's not the one single thing that fixes everything. There's a lot more for us to do, especially when it comes to really high volume scaling. So that's why we have a whole talk about it. So what do we need to do first? Well, one of the first things you'll take advantage of from a scaling perspective and actually continue to take advantage of throughout your journey is the AWS global infrastructure. So we have 19 regions around the world you can take advantage of to scale globally, each region consisting of multiple availability zones, and each availability zone isolated from one another in terms of power and networking and geographical risks, and yet close enough together to enable single-digit millisecond latency so that you can replicate your data synchronously. You can also take advantage of over 136 plus edge locations and caches, or caches, whichever you prefer, in order to put your content closer to your users so they don't have to go as far when they're making a request, so it's a great experience for them. But also, when that happens, your servers aren't taking that load. More on that later. Now, we have so many services to help you that you can take advantage of, and so many that have been announced this week. Really exciting stuff. But it's not to say you need to know everything and all of these services in order to get started. More just to keep in mind that we want to leverage these whenever we need something. We don't want to have to reinvent the wheel. Now, those services come in two flavors. Ones that are serverless or managed, where we control the scaling and availability. So they actually have that built in. And there's others that can be highly available and highly scalable with the right architecture. So as you're making decisions about which services to use, it's important to understand the difference. Now, this talk has been given every year at Reinvent since it started. And that's because scaling while your web application is gaining in popularity to ensure your users continue to have a great experience is a perennial issue. And it's one of the major value propositions of the cloud. Now, I'm going to take you on a journey. I'm going to wind the clock starting from one user all the way up to tens of millions. And the journey I go through, I'll choose some sequential steps that will help you sort of follow the things that you can do to help prepare for next levels of scale as you go. But it's not to say you have to follow this sequence. Depending on where you are today, you may choose to skip several steps or go right to a more sophisticated architecture from the beginning. Keep in mind there's going to be architectural trade-offs there. So with any of those, though, most of them are going to be two-way doors in the sense that we can always refactor and change. And indeed, most of what I talk about today will involve refactoring your architecture as you go. So best to just get building, measure the results, and learn from that and repeat, and continue to do that as quickly as you can. And I'll just mention some guiding tenets that I'd recommend you follow. And that's one, to identify and avoid undifferentiated heavy lifting. So these are the things that aren't core to what makes your organization and your business tick, what really differentiates you for your customers. And occasionally we will have to go off and shave some yaks, go and do some side things in order to do the main thing we're trying to do. But we want to try to avoid that whenever possible. If you're not sure what's differentiated and what's undifferentiated for you, I recommend taking a look at Wardley Maps. It's a great technique to investigate a solution you're building or even your business to identify what will really make a difference for you. Now, related to that is the idea that it's quite advantageous whenever you can choose serverless over managed, over build it yourself, because it's going to take away that undifferentiated heavy lifting for you. So, with that, let's start from the beginning. In day one, there's just one user, and it's you. The developer of the application, and you're going to need to run your application on a server. Okay, so let's get started. We're going to need a server, an IP address. We're going to need to route to that with a domain name. Now, you could use the Elastic Compute Cloud EC2 for that. Or another easy way to get started is with Lightsail. You can actually get access to a server in the cloud without having to know all the ins and outs of cloud in the beginning. If you're not familiar with that, you can start from $3.50 a day. And the nice thing about that is you can burst into full-blown EC2 and AWS, other services from there when you're ready. Now, whether you've used Lightsail or the Elastic Compute Cloud, one of the first things you're going to take advantage of from a scaling perspective is the instance type and size that you use. As you begin to monitor your application, and I recommend you do that right from the beginning, you'll see whether it has memory requirements that are higher than usual or really high CPU requirements, more I/O. And you can choose the instance type to match the needs of your applications. We have many, many different instance types that you can explore and experiment with. And the really nice thing about the cloud, as opposed to what would happen if you were doing this on premises, is that at any time you can stop your server, change that configuration parameter, and start it up again, and try another server without it really costing you anything to make that change. And you can do the same thing with the size of the instance. And this is one of the things we can take advantage of from a scaling perspective. We can make the box bigger. That'll give us more resources. We can take more users. Now, we can give you single instances with more than a petaflop of performance. But no, that's a supercomputer, basically. But no matter what, you're going to hit an endpoint eventually with a single instance. There's also another problem with that, and that is the architecture doesn't have any failover, no redundancy built in. We're going to have to deal with that fairly soon. So, let's start to scale. We want to go to more than one user. Humble beginnings. One of the first things we're going to do is separate our infrastructure so that our application and our database are running separately. This idea of separating your infrastructure and your application out so you can operate it separately and scale up one component or change the nature of the way one component is operated independently of the other is really fundamental to what I'm going to talk to you about today. If you get that principle, you're going to be able to apply it to other areas that I'm not even mentioning. Okay, so we've got our database separated. We're going to need to make a choice about the database we use. We can either just put it on another EC2 instance and then choose any database we like. The downside of that, though, is that we're going to have to manage, operate, administer that database. So we'll patch it, back it up, and do all the administration tasks. That's going to take time away from building our application. So another option is a managed database. I've just listed a few here. I think you're probably aware that there's a lot of databases available on the AWS platform. So we've got Relational Database Service, Dynamodb, and Neptune listed here. Representative of relational database, NoSQL, and graph databases. There's many others, depending on the nature of your application. Now, a relational database service gives you access to a lot of relational database engines, so open source engines like MariaDB, MySQL, Postgres, as well as proprietary databases like SQL Server and Oracle. And it also gives you access to Amazon Aurora, which is a database where you can run either a MySQL or Postgres database. It's compatible with either. So you can bring, if you've got a database already running on MySQL, you can bring it to Aurora or Postgres. And it's one of the fastest growing services on the AWS platform and the most popular. And that's because it's extremely high performance, about 5 times the equivalent open source engine, but also extremely cost effective. So you're getting enterprise grade performance with low cost. Now, why am I talking about this service? Well, it has some great advantages from a scaling perspective. It's going to automatically scale your storage tier without you having to get involved in that. That's a great advantage. It's going to give you up to 15 read replicas. Not to say right at the beginning, but as you need them, you can tap into them. If you're not sure why read replicas are important, you'll understand that soon. That's going to help us scale. And it's replicating your data 6 ways across 3 availability zones. So that's giving you really high resilience to your data. Now, one of the downsides of operating a SQL database is you have to provision the capacity that the database needs, at least for the foreseeable future. So in a given weekly cycle, you need to provision and make sure that you've got that peak covered. And not only that, when your users drop off, you're still going to need to have that server running. Not very cloud. Which is why the serverless option with Aurora is fantastic. This gives you the ability to have your compute scaled in the background for you as your request volumes increase on your database layer. Aurora will automatically scale up the compute you have access to, and conversely, when that decreases, it'll scale back down. And when it detects inactivity, it'll actually shut it down completely for you. It's a great advantage. All right, another thing that you'll have to contend with early on is whether to go NoSQL from the beginning, or SQL. And it's really popular to go NoSQL from the beginning these days. It's quite common. I'm going to recommend that you actually start with a SQL database. The reason for that is it's very well-known technology. There's lots of code examples, communities, tools to help you. And you're really not going to break SQL technology and even in millions of users. So many massive sites are running using this technology today. And we've got some really well understood patterns for scalability that I'm going to go through as well. Now, the caveat to that is you may want to use NoSQL in certain cases. And that could be if you have large amounts of data. And if you thought, that's me, I've got lots of data. Let me just clarify what I mean. Around 5 terabytes per year or more, or just a really data-intensive workload. Other reasons you might want to go NoSQL from the beginning is that your data set actually matches to a NoSQL database. So it's very document-driven or key value pairs. It's very data-intensive. Those types of things might drive you towards that technology. And equally, there might be other databases that you're driven to because of the nature of your application and the data that you're actually using. Another thing you're going to need to contend with early on, when you go from more than one user, is actually the code that you need to support those users. Sign in, sign out, registration, etc. Now, if you're like me and you've built lots of web applications in the past, you would have implemented these user stories over and over and over and over and over again. Now, you can continue to do that, or another option is to use Amazon Cognito, which implements all of that for you. Save yourself some sprint cycles, get started a little earlier into the rest of your code. It gives you all of that sign in, sign out, registration, multi-factor authentication, a user database, as well as federation and other sorts of things you'd like. Now, since we're talking about security, let me just go through a quick checklist. Even though this is to talk about scalability, we want to make sure security is well in place so that we have confidence in order to scale. So it starts with IAM, Identity and Access Management. On the cloud, as opposed to on premises, we now have the ability to make sure we authenticate and authorize anyone who does anything to our infrastructure. So it's going to be one of the fundamental building blocks we can use in order to control what happens there. Now, as a minimum, I'd also recommend you have CloudTrail enabled. That's giving you an audit trail of everything that happens on there to your accounts and your resources. I'd recommend you enable guard duty. This is going to continuously monitor for any unauthorized or malicious behavior and alert you to let you know that this is going on. AWS Shield. Everyone on the AWS cloud that's connecting to the internet is protected by AWS Shield. And it's protecting you from the vast majority of denial of service attacks. Now, you can get a high level of protection with a Shield Advanced as well. It'll give you high levels of protection and support. Now, some other services that I'd recommend and just mention is Secrets Manager. And this is going to help you externalize your database passwords or any other secrets that are reused by your application so that you don't actually accidentally put them into your source code. AWS WAF will give you application layer protection from SQL scripting or cross-site scripting, SQL injection, apologies. And then, of course, you've got Certificate Manager giving you encryption in transit and Key Management Service giving you encryption at rest. And finally, I'll mention Config, which gives you a complete configuration of all of your AWS resources, which you can use in conjunction with config rules to ensure your applications and all of your accounts are compliant with your policies, your security policies at all times, giving you continuous assurance. Okay, so let's get scaling. Still humble beginnings, and you can imagine I'm winding the clock forward, so this is going to start getting fast. You wouldn't necessarily make all of these changes one day after another. It would depend on what's happening in your application. So one of the first things that I'm going to suggest you do in order to prepare yourself for scaling is actually use the relational database service if you're using a SQL database. One reason is to take away that heavy lifting. Another reason is because it gives you features that will help you scale a lot more easily. So we'll get to those in a moment. So let's go for thousands of users. And that's a majority of you here today And the first thing we're going to do with thousands of users is have the ability to scale out. And we're going to take advantage of these availability zones to give us resilience across the availability zones. We're also going to take advantage of a feature on the relational database service called multi-AZ database. So where we can actually create a standby database that's synchronously replicated for us. Now, this load balancing that's happening between the application tier at the top is enabled by the Elastic Load Balancer. So you need to choose an Elastic Load Balancer. There's a few different options to choose from. I'm going to recommend you choose the Application Load Balancer in most cases. It gives you the ability to automatically monitor the health of all of your instances so that it won't route to any instances that become unhealthy or out of service. It also has some great advanced features like content-based routing that you may use down the track. Okay, so with this in place now, we have access to two of the most powerful levers that are available to us from a scaling perspective. One being scaling up in terms of the size of resources we use, and the other being scaling out to the number of servers. And this is going to hold us in good stead. As we accumulate users, we can start to tweak and use those levers as we go, and we're going to continuously tap into that. Let's go for tens of thousands of users now. Starting to get serious. At this level, we're fanning out the number of servers in the application tier. And I mentioned before, the Elastic Load Balancer isn't a single instance. It's a managed service. It's serverless. So it's not a single point of failure. It's going to be automatically managed in terms of the number of requests it's getting. And then it will be able to scale out all of those requests to the application tier. Now that poor main database might start seeing some contention if that's the case, if you start scaling out really, really far. So one of the things you can do is take advantage of another relational database service feature to have read replicas. Some of the database engines have this available, and by having read replicas, you're able to offload that read traffic from your primary database onto those read replicas. And that's going to take a lot of that load off that main database. That's also going to affect what size database you need if you're able to spread that load, right? Now, as we grow, we can start to shift some load around even more. One of the first things we could do is take our static content and put it in S3, the simple storage service. Let that be served over there, and even cache that content using CloudFront, Content Delivery Network. So Amazon S3 is one of the most underrated services on the AWS platform. It's one of my favorite services. That's because it's extremely highly durable. So it's designed for 11 nines of durability, meaning that if you have something like 10,000 objects or so, you can keep those objects for 10 million years. You could expect to maybe lose one after that time. The other thing is it's incredibly scalable, pretty much infinitely scalable in terms of storage and request volume. So that's just going to be taken care of for you. CloudFront, our content delivery network, can be used to take advantage of those edge locations and put your content closer to where your users are. And on a content delivery network, it's going to reduce both the load times for our users as well as our server load. Now, interestingly, that's not just for static content. That's also for dynamic content that's constantly changing and may not be able to be cached at all, if not for very long. And that's because CloudFront is actually going to accelerate the connectivity between your resources in your VPC and those edge locations. Now, the other graph at the bottom right is showing you the experience one of our customers had. They were getting around 5 gigabits per second in traffic on a normal day, and then they suddenly had a massive spike, and they got up to 70 gigabits per second in request volume. Now, the interesting thing that happened here is that they actually absorbed all of those requests. CloudFront absorbed it. and their web servers didn't have to take any of that traffic. So this is a really powerful capability that you can tap into just by putting that in front of your application. Now, as we grow again, we can start to spread more load, use caching or caching even further by using Elasticache. Now we're caching our database requests. Whenever we're able to cache our database requests, we don't have to go all the way to the database for that information, save our database from some of that load. So Amazon Elasticache gives you either a managed Memcached or Redis cluster. It'll scale up in terms of the amount of nodes, and it will reduce those requests when the cache is hit down to single-digit milliseconds. Shift the load around even more. Now you could tap into something like a NoSQL database for storing your session content separately from your relational database server. So Amazon Dynamodb is a good option for that. It's a NoSQL database. It allows you to provision throughput in terms of both read and write performance, and it will automatically scale that for you. And also, if you start to grow and want to go global, you can actually access a multi-master database that will replicate your data all around the world if you choose to use that. Now, one service that's really powerful when you start to think about moving your data from one database to another is the database migration service. This is where you can actually have a source database and a target database, and it will fully load the data from one to the other, and then keep the two in sync using change data capture, which means it doesn't adversely affect the performance of the source database. Once you're ready, you can fail that over to the new target. Now, this could be when you're wanting to move your data from MySQL to Aurora, or from a SQL database to a NoSQL database. And the reason for this is you can actually use the database migration service in conjunction with the schema conversion toolkit in order to change the schema and the way the data is actually stored. And this gives you the ability to do heterogeneous migrations. So you can go from even Oracle to MySQL or Postgres. So we've lightened up the infrastructure, we've spread the load. Remember, I talked about separating those components and spreading the load is a key principle that we're going to continue to tap into. And this is a good time to go back to that, what I mentioned at the beginning of the talk, auto-scaling. If you look at a typical week at Amazon.com, you'll see that the traffic is increasing during the day and then decreasing at night on a pretty regular pattern. And if we provision capacity for that above what we're seeing in those peaks, this is actually pretty conservative. We probably want to make sure that we're provisioning above that. We'll actually have a fair bit of our servers that are being underutilized. Now, what about what happens in November? Well, at Amazon.com, we see the steady increase through November of request volume until we see massive spikes for Black Friday and Cyber Monday, so earlier this week. If we provision for that, then most of the capacity we have is not utilized. And this is not a good situation to be in. What we'd really prefer is to have our capacity increased in lockstep with our request volume and decreased again when we don't need it to be there anymore. So auto-scaling lets us do this. It's actually really easy to use. The command to set up an auto-scaling group is down the bottom there. And you configure your auto-scaling group by giving it a minimum and maximum. And then based on CloudWatch alarms as to whether your CPU performance is getting too high or the request volume is getting too large, an alarm will fire and auto-scaling will automatically add a node into your cluster. And conversely, when the CPU drops back down or the request volume drops back down, another alarm will fire and the node will be taken out of your cluster for you automatically. So if we put all that together, we imagine going forward in time and we've taken advantage of all those aspects, we'd see something like this. We've got our read replicas, we're caching, we've offloaded some of our content to NoSQL, we're offloading our static content to S3, we're caching the whole thing at CloudFront, we're auto-scaling, And we've got an auto-scaling group in each of the availability zones we have access to. Now, I'm only depicting 2, but we could have 3 or 4 or 5, depending on the region that we're operating in. But what I'd actually prefer to do is just have a single auto-scaling group spanning all of those availability zones and automatically balancing the servers for me, so I don't have to make any of those changes myself. All right, so up to now, we've already taken advantage of automation to get the auto-scaling going. But as we continue to refactor, it will be advantageous for us if we're able to automatically provision our infrastructure. Because as we refactor, that'll make the work our team has to do to provision those refactored changes a lot easier. We can automatically test them, for example. We can do blue-green deployment, things like that. So let's talk about some of the ways in which you can do that. One is with Aws Systems Manager. And this lets you automate administration tasks for your servers in the cloud or on premises. It also gives you access to the shell of those servers without you having to run Bastion or jump boxes, which is really cool. It's very reasonably priced because you only pay for the EC2 instances that get run in order to complete those administration tasks. Other infrastructure automation tools that you have available, there's lots of options, and they tend to range from ones that give you lots of convenience but not much control to ones that give you lots of control but aren't as convenient. Let's go through a few of them. The first thing is all of the services on the AWS platform have an API that you can tap into to actually control programmatically the way your resources work. So you can automate your infrastructure that way. Now, it gives you a vast amount of control, but you are going to need to do all those changes yourself. At the other end of the spectrum, if you like to work in tools like Chef or Puppet, you can use OpsWorks as a managed service for that. Or if you'd like to just give us your application, Elastic Beanstalk will take your application, determine what infrastructure that application needs, and automatically provision and manage that for you. Or if you prefer containers, we can give you a managed control plane with either the Elastic Container Service or the Elastic Kubernetes Service. Or if you'd prefer to let AWS manage the control plane for you, you can use Fargate. Just give us your container and we'll do the rest. And finally, if you use CloudFormation, you can actually declaratively define your infrastructure as code. And CloudFormation is smart enough to know which order in order to deploy that code, that infrastructure. It'll know whether it needs to make a small change or a large change when you're going from one release to another. It'll determine that for you. And it'll automatically roll back if it encounters any issues. Now, this concept of treating your infrastructure as code or immutable infrastructure is incredibly powerful because it allows you to start treating your infrastructure as part of your application code. And this means you can start to use the same CI/CD practices and DevOps practices you're using for your application with your infrastructure. Some tools we have available to help you do that. There's lots of third-party tools out there that are really popular. These are just some of the ones that are on the AWS platform. You've got Cloud9, which is an IDE in the cloud, which is very cloud integrated. It makes it really easy to do cloud programming. You've got Code Commit for managing your Git repos, Code Build for automatically deploying, and Code Deploy for automatically deploying. So build for building, deploy for deploying. And the whole CI/CD pipeline can be managed by Code Pipeline. Now, you can set up pretty much any CI/CD pipeline that you want using these tools. You can have really complex and powerful setups. You just need to set it up. Or another option you've got is to use CodeStar, which will automatically provision and configure all of those CI/CD tools that I mentioned previously for you, depending on the type of project you're working on. So that can be a great advantage. Now, I've mentioned monitoring a few times, but we're talking about getting into 500,000 or so users now in the type of application and infrastructure setup we've got. So we're going to want to get as much as we can out of all of our platform. So monitoring is going to become really important. Now there's many third-party tools available for this. If you go through the Partner Pavilion, you'll be able to see many different options. You can also use some AWS tools. The things that you would like to monitor for are things like host-level metrics with CPU, memory, I/O, that type of thing. Again, helping you decide which type of instance to use, which size of instance to use. You can look at aggregate level metrics, so things like response time and other metrics like that. A key thing to look out for there is not just average. Average things tend to be quite average. So take advantage of percentiles whenever you can. So, what's the worst 10% of the requests that I'm seeing right now? Or what's the worst 1%? And that'll tend to help you really hone in on those issues you're having. You can use your P99 and P90 and things like that. Centralizing your logs is also really critical to make sure that you're able to track any kind of performance issues, hotspots, errors that are happening, do some troubleshooting. And finally, one of the most important things is what's actually happening for your users, so your external site performance. Now, a lot of this you can get access to through Amazon CloudWatch. It gives you all of that auto-scaling capability that I mentioned earlier, but as well as that, you can create your own dashboards and metrics for all sorts of other things you want to keep track of, firing alarms. And CloudWatch is also the source of where you can centralize your logs and will collect any events that are happening in your system. So these days, there are a lot of events that fire off as a result of changes in your infrastructure and application. And you can be tapping into those and using them to automate. Okay, so up to now, we've focused on infrastructure changes. That's fair enough. We've been able to get by to a large degree, up to a very large number of users by doing that. And I've assumed up to now that you've got a monolithic application. Now, monolithic application meaning that our application's in one code base. Now, the problem with that is that if we want to actually break that apart and scale it separately, we can't. So perhaps SOA can help. So what's that? Let's get our browser out again and have a look. If we search for it, we get lots of hits and some things that may not be that helpful. But one thing that is, service-oriented architecture. So service-oriented architecture is about breaking our application into separate components that are going to collaborate together in order to get this work done for our application. And they're going to do that by communicating through well-designed interfaces. This is going to enable us to operate and scale those components of our system independently. As we start to tap into these technologies and we start to add capabilities to our system, let's remember to try to use serverless whenever we can. Many different serverless capabilities available that you can stitch together to perform different aspects of your system as you start to tease them apart. And one of the things that you could enable with that, using something like the simple queuing service or the simple notification service, is loose coupling. Once we get to the point where those components are separated, it may be that one component is able to do some of the work that we need in the background and not necessarily have to respond synchronously all the time. And here's where we can tap into queuing. That way, we can really start to play with exactly how we scale those individual components. Another pattern that's becoming really important and that we're focusing on more and more and more is event-driven programming. Has some great advantages, and you can use Aws Lambda to run your code. Hopefully you saw the keynote today and some of the announcements for Aws Lambda. You can run your code in whatever language you decide. We've got lots of ones that are built in, and you can bring your own code now. It's serverless, so it's implicitly scaling, and it's going to run your code just for the moment that it runs, just that it needs to, in response to events that you're listening, that you've set it to listen for. And that could be events that are generated from other AWS services, like these are a few examples here. S3 bucket, Something gets added to your S3 bucket, you automatically go and process it, for example, but your code isn't run in the meantime. There's no idle time here. If you're responding to a Dynamodb stream or a Kinesis stream, there's many different options available for this today. Now, if you're using those components, you've separated the components of your system, and you're using queuing and event-driven programming, this is really going to enable a lot of scaling in your system. You're going to start to be able to support quite a lot of users by doing these types of things in your infrastructure. And if you take that concept even further of a serverless application with broken apart components, you can actually create the entire application in a serverless way. And here's an example where you're using S3 to do the static content, using Lambda to do the compute, API gateway to control the access to that compute, Dynamodb is the database, and caching the whole thing with CloudFront. Where's our user interface code going to run, though? Well, here we can actually have the ultimate in distributed computing by allowing our user interface code to run on our users' browsers. We can do that using a serverless application, a single page application. We can use one of these frameworks to do that, Ember or React or Angular. And AWS put out AWS Amplify to make it really easy to make single page applications that integrate into the cloud. And you can use that either in pure JavaScript or in conjunction with one of the frameworks that you prefer to use. Taking the service-oriented architecture concept to its ultimate, you can even explore microservices, where you're componentizing down the aspects of your application to their minimum parts, the minimum that they need to do in order to actually get their work done. And they'll look after the data that they're responsible for, and they'll collaborate together. Many different ways to implement this pattern. One example is with the services that I mentioned earlier, API Gateway and Lambda. There's many others. Now, if you're starting to look at this coming from a monolithic application perspective and going, well, this is actually going to get pretty complicated, you'd be right. This is starting to get complicated. This is a trade-off we have to make in order to get this distributed capability and operate these individual components. We also get some advantages on top of the distribution. We start to be able to divvy up the work amongst more teams and scale our development capability. But in terms of keeping track of what's going on, how do we know where those request volumes are going and how do we pinpoint problems? I recommend to look at AWS X-Ray at this stage, because it'll give you the ability to pinpoint any issues, track where the requests are going, and help ensure everything is operating smoothly. For example, it'll automatically generate a call graph of the requests that it sees going through your system, and it'll show you what's happening with those calls. And you can even dive into any one of these points and find out a trace of what's actually going on in detail. So let's go for millions of users with all of this capability we've built up. We've taken all of these different aspects and approaches together to come up with something like this. Here we've got our auto-scaling, we've got our, across multiple AZs, read replicas, we're caching at multiple levels. And we've introduced these other aspects with respect to service-oriented architecture where we've got an API in the back end being load balanced for us or via API gateway. And we've got loose coupling where some of the compute is actually being managed by a worker tier that's operated off of a queue and just processing those requests in the background. We're doing some event-driven programming with AWS Lambda, coming off any of the events that are occurring on our S3 or Dynamodb or other events in our system. And we can even introduce serverless web applications at this stage to start offloading some of the new features we have into serverless using Dynamodb, Lambda, and API Gateway. So what are the next big steps? if you're getting to this stage and you've been trying to tease apart your application in order to get this massive amount of scale, one of the issues you'll have is the difficulty there actually is in achieving service-oriented architecture and microservices with an application that's in flight and at scale. And sometimes you'll be a little bit behind where you'd like to be. One of the things that you can do at the database tier to help with the contention you might be experiencing if you haven't been able to separate these components out as much as you'd like is something like federation, where you can actually split apart a single database in a very similar fashion as you would get if you had microservices or service-oriented architecture working. So for example here, we're splitting one database out, and we've got our forums, our users, and our products in actually separate databases. And we're operating them separately. Similar idea is you could take one of those databases, or a part of your database, and split in terms of the actual data in that single database using a partition key or a shard key to separate it into multiple databases. So here we're separating our users database into 3 separate databases. So you could have A to K, for example, of your users in one database. And you can also tap more into NoSQL at this stage, looking for opportunities, whether you've got hot tables, reference data, key data pairs, metadata lookup tables, that type of thing. You start to look for more opportunities to separate your data out. So let's have a quick review of what we've gone through today. You've got your multi-AZ infrastructure. You're taking advantage of self-scaling services whenever you can, because that means you don't have to operate, keep track of, do all the automation for, and all the work for those things. We're building redundancy into multiple levels of our infrastructure. We're caching both inside and outside of our infrastructure. We've automated the deployment of our infrastructure, and that way we've been able to refactor more easily. And we've been able to build more resilience into our system by ensuring automating testing is happening, and by ensuring that we're not making manual changes in production. It's all automated. We've tested it before it's actually gone there. We've got good metrics. We're really getting the most out of our system. We've got good logging. We've split our application up as much as we can using service-oriented architecture or even microservices. Now, with auto-scaling, I left that to last. It's not to say you might not have used that right from the beginning, but it's more to say that to be aware of all these other things that you can actually take advantage of, especially at large scale. We don't want to reinvent the wheel, and I did suggest using SQL from the beginning. This is going to enable us to have tens of millions of users, really potentially to infinity. Going beyond that, wasn't anyone today. We've had a few other sessions where there's been people who've been dealing with tens of millions of users. This is a really high value problem in the sense you're going to have a lot of resources to apply to the problem at this stage. You're going to be able to get into custom solutions, a lot more into SOA, fine tuning, going really deep into your stack and working out what's going on. Again, you want to build serverless whenever possible. Now, if you liked the concepts that we went through today in theory and would like to actually try some of these things out yourself, we actually have a builder session running this afternoon that lets you throw load at an application, break it basically, and then refactor it and see how differences you can make at different levels of volume to get, slowly get more and more. Next steps, we've got lots of resources to help you with respect to documentation. The architecture side has a lot of resources related to these patterns I've mentioned. The well-architected website has great tips on how to make sure your application is secure and performant and reliable, cost-effective, and well-operated. And we released the well-architected review tool today. You can tap into solutions and quick starts in order to get a jump start or a reference implementation for a given architecture you're trying to build, where we'll actually provide the code for you on your infrastructure code. And when you're looking at some of these new services, you can tap into the free tier in a lot of cases. Now, you're not alone in this journey. we've got the forums, we've got answers, and you can also tap into premium support, which is an opt-in service. We don't charge you for that unless you opt into it. But I've found in the past, as a customer previously myself, and now with my customers, that premium support can become part of your team, a virtual part of your team. Because you don't have to just ask them when something's going wrong. You can actually log a case and say, how do I do this? Is this the right way to do this? Can you give me some advice? And you've got a solutions architect like myself to help you as well. So no matter where you are on your journey to tens of millions of users, we want to help you get there. Thanks very much for your time. I hope you have a fantastic reInvent. Please fill out the surveys. Cheers. If there's any questions, please come up.